In this reaction, we're asked to write the formation reaction for sucrose. When we're asked to write a chemical reaction, really it means we need to balance it out. So we're asked to balance the formation reaction of sucrose. Sucrose is C12H22O11. What we have to remember is that formation is always the creation of a compound out of its elements. So if we have carbons, we know that we're going to have carbon reacting in this reaction. We have hydrogen, so we know we have hydrogen gas. You have to remember that hydrogen gas is H2, not just H. And we have oxygen gas as well. Again, O2, not just O. Those three elements will react together to form sucrose. C12H22O11. I have carbon, hydrogen, oxygen as my compounds. And I'm going to split my reaction in half so I can count up how many we have each in the products and the reactants. So we have 1, 2, and 2, and then 12, 22, and 11. First thing that I'm going to want to look at in this reaction is I want to look at those H2 and O2s, because each of those have to be an even number. I see over on this side, 22 is an even number. That can balance nicely with 2, but 11 isn't. 11 will be an odd number. So I want to find the lowest common multiple of 11 and 2, and that's going to be 22. So I'm going to stick a 2 in front of my sucrose, and I'm going to stick an 11 in front of my oxygen. Now, whatever I do to one element in the sucrose, I have to do to all of them. So that's going to actually double everything on this side. Okay, lowest common multiple between 2 and 44 is going to be 44. So I'm going to need 22 hydrogens. And then lowest common multiple between 1 and 24 is, of course, 24. So I need 24 carbons. And there's my balanced chemical reaction. It's going to take 24 carbons, 22 hydrogens, 11 oxygens to make 2 molecules of sucrose in a formation reaction. Here we have another reaction that we want to balance, but this time it's decomposition instead of formation. In a decomposition reaction, you have a compound becoming elements. So here we're asked to write the decomposition reaction of alcohol. Other name for alcohol is ethanol, and its formula is C2H5OH. So we are going to start this time with C2H5OH. Its state will be aqueous. It's going to break down into carbon. Just going to move that over a little. It'll break down into carbon, hydrogen, oxygen. Same rules apply. Hydrogen and oxygen need to be H2 and O2. Okay, we have carbon, hydrogen, oxygen as our elements again. Break into our reactants and products. I have 2 carbons. I have 6 hydrogens in my reactants. Don't forget about that one on the end. And I have 1 oxygen. Then I have 1, 2, and 2 in my products. Again, what I want to look for here is a mismatch between evens and odds with the hydrogens and oxygens. And again, we see oxygen as the culprit here. You have 1 and 2. Easy to balance out though. Lowest common multiple is 2. That means I'm going to have 2 ethanols in this reaction involved. It also means I need to double everything else. So I have 12 hydrogens and 4 carbons. 4 and 1 nicely balance out to 4. So I'm going to stick a 4 in front of the carbons, and 6 and 2 give us 12. So I need 6 hydrogens. So 2 ethanols will be able to decompose into 4 carbons, 6 hydrogens, and 1 oxygen.